Hey, hello everyone and welcome. I hope you are doing well, and today a new episode about our Kubernetes training. This is really important, of course, for your career path. This is really important to your knowledge. And today I want to show you how or what is rollout and the history in the kubectl command line. So this is really interesting because this is the difference between what is a deployment and what is a replica set. Of course, the deployment had on the replica set what we named a strategy, and today we will discover what is the strategy. So the first thing that we need to know about the strategy, this is the type about this strategy. For example, you have two kinds of strategy. The first one is the recreate. For example, if you deploy and you have a deployment with 10 pods into it, 10 replicas, and you want to recreate all replicas in the same time, you can use the type equal to recreate. This is not really current to use it because it's a big change into your infrastructure and your Kubernetes cluster. For example, if you want to upgrade something and you have 10 replicas in the same time, all replicas will be terminating and be starting. So this is all in the same time. And the second type is the rolling update, a really useful type, of course, because this is a fine-grade pod replacement. For example, if you have 10 pods, in this case, you can manage how you can upgrade all pods into your 10 pods. For example, you can set how many pods you want in the maximum to be unavailable. So, for example, in this example, we can see that we have a 25%. And, for example, you can decide that you want or you accept during only this rolling update that Kubernetes can spawn more pods than the max replicas. For example, in this example, we accept that to have 25% more replicas. So this is really interesting to have it. Of course, here it's in percent, but you can use, for example, an absolute value, of course. So this is two kinds, the recreate and the rolling update mode. And by default, of course, Kubernetes uses the rolling update because this is more smoothly to upgrade with this kind of strategy. So we already saw that, okay. So we have the max surge. Max surge, this is how many pods you can accept upper to the max replicas by default of your deployment, and the max unavailable, how many pods you can lose during this rolling update. After that, you have other really interesting settings. For example, the first one is the progress deadline seconds. This is how many and which threshold you can use to decide when your deployment fade. So this is really interesting to set it because for example, you have 10 pods again, and so Kubernetes begin to upgrade each pod one per one, for example, and that takes too lot of time, and you can decide with these settings the entire time for the entire deployment, and if this threshold is over, so Kubernetes can decide that to set this deployment as failed. The second one is the min ready seconds. This is the minimum of time for a pod to be ready. Of course, you need to synchronize it with the progress deadline seconds. You can't have a min ready seconds upper to the progress deadline seconds. So if you make it, it's an error, and of course it's not really intelligent to do it. After that, and we will see it just after with a little demo, you have the revision history limit. So it's another part about what provides the deployment. The deployment provides and allows you to roll back and to keep the previous version of your deployment. This is really interesting. This is like, for example, a Git, and you can commit each deployment to comment this deployment, and if you want, you can roll back. But you can set how many version, how many revision you want to keep in the history. So you can set the revision history limit to not have too many revision and too many version into it. By default, this parameter is set, you can see, to 10. And now we can discover the command line, and we will see the kubectl rollout history to list the entire history about what we have. The kubectl rollout history deployment to know a specific deployment history, for example, a deployment like a demo. And you can, for example, discover a dedicated specific manifest about one of these revision. For example, here you can see the -- revision, and you can see we can discover what we have in the revision number 3. And after that, you can check, and for example, if you have a bash script in your CI/CD or stuff like that to have some automation, you can use the kubectl rollout status deployment for a deployment, and the name of this deployment to check where your deployment is in the progress. So for example, if it's okay, or if it's in failed status, you have a return code about the status of this command, and that is in sync with your deployment. And if you want, you can, of course, if we have some version, maybe you want to roll back. This is really interesting. For example, in production, you make some stuff with automation, and in a non-call, for example, you need to roll back quickly, and you can use the kubectl rollout undo deployment, the name of this deployment, and -2 revision, and the number of this revision where you want to target it, and you want to roll back it, for example, here in the 3 revision. And after that, during a deployment, you can pause the deployment, and after some check, etc., you can resume this deployment, of course, with kubectl rollout pause deployments to pause it, and kubectl rollout resume deployment, and the name of this deployment to continue it. And if you want, you can commit or comment your deployment. When you do that, you can, for example, set an annotation for your deployment and use the specific and dedicated annotation, the key kubernetes.io/change cause. And if you want, you can set a value, for example, so for what you want, for example, move from version XXX and to version YYY. This is just an example. And I think that's it. And now it's time to demo. I need to remember what I want to show you. And now what we want to do, we want to create a deployment. So I can use just remember what we saw in the previous video, we want, for example, a deployment, and we can use kubectl create deployment. This is the kind of resource that we want to create, and we want to create a deployment. The name of our deployment, for example, my Nginx, and the image. So I want to use an image, Nginx image, with a tag, so I can, for example, take a real version. So we just want to check Docker Nginx image tags to show which tags do we have, and what we have into it. We have, for example, I don't know the latest version of our Nginx. This is 1.27.3. So I can check. We can check with a search. Where is it? Yeah, 1.27.3, for example. What we have into these tags. And alp. Yes, all like this. Perfect. So what we want to do, we want to, for example, to set this one to 1.26.1, for example, and now we create a pod. So kubectl get pod. So maybe just before we can delete, sorry, we can delete the deployment name my Nginx, and we just want to have the manifest, the YAML manifest, my Nginx, like here, and we can reuse the command line about kubectl create, but with a dry run command. So we already saw that dry run, so equal to a client, and we want to push it into a YAML file. So I want to have a YAML. So where is the problem? Got to in name. Kubectl create. What we create an Nginx. It's okay. Image equal, maybe. No, it's here. Equal client. Okay, and now I can push it in a specific file, for example, my nginx.yml, like here. And now I can edit this file. I can remove, for example, creation timestamp, the number of replica, what I want to have. This is really interesting for this demo, to have many replicas to really show a deployment, and to have the time to see what we want to show, and the strategy. By default, for example, you can use the type, and we can set it, be careful to the indentation here, and we can set it to recreate, like this, I think, yeah. And after that, I can remove the creation timestamp here. We have the our version, and we can destroy our resources. So now kubectl apply. You can use your alias bash alias with a K to kubectl apply -f and our file. So now I can get kubectl get pod, and we have many pods for our Nginx deployment. Okay, it's cool. Now what we all pods are running perfect. And after that, what I want to do, I want to upgrade. So I can open another terminal and go in this new in our server K0s10. Okay, and I can, for example, use the watch command line and a watch on kubectl get pods to be sure to see all change into our cluster. So we have more than okay. And after that, what we want to do, we want to upgrade, for example, our pods. So I can maybe, yes, I can, for example, here add so I can keep on the left, on the terminal on the left, we can keep here all the pods, and on the right we can use the K0S10 here server, and we can edit our manifest here. And now what we want to do, we want to push a new version, for example, for our Nginx, and remember that we use the type, the strategy type set to recreate. So you can see you can see that if we push this manifest with the recreate, you can see here all pods are terminating really quickly, and after that all pods are recreating in our Kubernetes cluster, and of course it's really quick. But if you are in production, it's maybe you are pretty sure to have a downtime. So this is not really what you want to have in production. So this is why you can use the another strategy, for example here, and you want to use the rolling update strategy here, rolling update. And for rolling update, you can set some specific settings about it. And in these specific settings, so you can keep, of course, default settings, but in our case, we want to discover some stuff. And for example, you can set here the strategy to rolling update, so the type to rolling update. But if you use the rolling update type, you need to set the key rolling update in your YAML file. So we need to set it, of course, and I can add it here, rolling update. Be careful to uppercase and the lowercase. This is really important. Not the same thing if it's in the type or in the key. And after that, I can set, for example, max surge. Be careful to uppercase again. And I want, for example, I allow our Kubernetes cluster to have, by default, we have 30 replicas, and I accept to have 40 replicas during the upgrade. So to do that, I allow to have 10 replicas more than the max replicas. And for example, I can decide to have max unavailable set to 1. This is, in this case, Kubernetes just stop one pod per one pod and ensure to have a running pod after each one. So this is really interesting to do it really smoothly, but if you have many pods, like in this case, this is not really quick, of course. So to do that, we can use kubectl apply, and of course we apply our deployment, and now we just wait a few seconds. So take a little bit of time. So yes, no, what? Oh, maybe. What? Do I have a change on it? Yes, I think yes. So I can push the .3 version and apply it again. Okay, so now the version doesn't exist. Yes, a little mistake. I can so I can use, for example, here the 27.1. I hope this version exists, and I push it again. So what we can see, yes, in this case, what we see, we can see that we have 10 pods more than our max replicas. So here we have 40 pods, and of course it's really quick because we accept 10 pods more, but we don't want to process, so we want to process max unavailable to 1, but max unavailable is just the number of pods into not the 40 but the 30 replicas that we accept to lose. So of course, if we accept to have 10 pods over our 30, we have 40 pods, and of course we have no pods unavailable if it works well. So we can't see anything with this setting. This is just what I want to say you. So to see a really interesting thing, we can set the max surge to 0, but max unavailable to 1. And that change many things. We will set it, we will see it, sorry. And if I apply it again, I hope yes. And in this case, what the cluster and the scheduler do, they just upgrade each pod one per one, and with no more than our max replicas into our Kubernetes cluster. So one pod, and the pod is killed, is terminating. After that, the pod, new pod is container creating, and etc. for our 30 pods. So of course that takes a lot of time. And now it's okay. So that take around 30 seconds, or maybe, of course, but it's really smoothly and really interesting. Of course, in production, you need to set it exactly, and we will see in another video how to use else check and to take more time during our upgrades to be sure that, for example, our Nginx respond on the default port, and maybe you want to take the time to check it before before to switch to another upgrade. Okay, and so after that you have the progress deadline. So I haven't any demo for that. And now what we want to, what we can see, we can use, for example, kubectl rollout and history. And for that, of course, we need to specify which resource that we want to check. And in this case, we can check, for example, deployment, and our so in our case we have only one deployment, but you can add the name of this deployment, and you can see here this is the number and each revision. Do we push into did we push into the cluster, the 1, the 2, the 3, the 4, and the 5. And if you want to check, for example, in which version we are, we can use kubectl describe deployment and the name of our deployment, for example, my Nginx, and if we do that, you can see here in annotation a dedicated key for the deployment.kubernetes.io/revision and the number of this revision. Here we are in the version 5, for example. So in the version 5, for example. So maybe you want to see what we already have into the previous version, for example, the 3 version, and you can do it with the kubectl rollout history deployment, and you can, for example, use the revision here. And as a revision, you can you want to see, for example, the 3, and in this output you can see which change was pushed in the revision 3. And for example, you can see the image version, the image tag, set to 1.26.3. Okay, and for example, you can check the revision 4, and in the revision 4, we pushed the tag 1.27.1. So this is really interesting to know that. Of course, you can, for example, roll back now. So we are in the 5 revision, but maybe you want to roll back, and to do that you can use the kubectl rollout undo. Kubectl rollout undo, and what we want to undo, this is the deployment, and the deployment named Nginx, and we want to go to a specific revision, for example --2 revision, and we want to go on the 3 revision, like here, and in the 3 the target will be 1.26.3, and if I push it now, of course, a new upgrade. Yes, this is the image error. I can push the revision .1, for example, and with the .1 now we push a new rolling update, of course, and container will be upgraded in 1/1. And if we check which version do we have into it, you can use a kubectl get pod, for example, and the name, or maybe kubectl get deployment, and we want to have to check the version and the tag version about our my Nginx deployment, and dash o YAML, like here. And if you check into it, what we have our first version of our Nginx. This is 1.26.1. Okay, perfect. And this is, so of course it's really interesting to have it. If you check the history again, like here, you can see so that we have a new version, and the latest version, the 7 here, this is like our previous version number 1. So this is why we don't see the number 1 version. And remember that you can set the revision history limit. So this is the number of revision you can see here. And of course, you can tell me that if you use so the same command line, we can't see any change cause here. You can't see so anything, and you don't know which version do we push, etc. And you want to push a command, for example, on it. And to do that, so this is a little bit easy, if I remember well. You can use the so of course you want to push it with your manifest deployment, and you want to add an annotation to do that. So annotation, so in annotations, and which annotation? This is this annotation. So kubernetes.io, so kubernetes.io slash the change cause. Of course, you can see here we have change cause, so in uppercase, but here we set it with lowercase, change cause, and now you can add a command. So for example, here we can set push version from 1.26.1 to 1.27.1, for example. And of course we set it to .1, and if we push it, kubectl apply -f and our manifest. Of course we have our rolling update deployment on the left, and if we check the history again, like here, what we can see our command here. So this is really, very interesting to have it. Of course, if you use some automation and templating like Helm, you can push it automatically. So this is really, really interesting to have it and to be sure to push it. So another thing is really, really interesting to show or to have. This is the impact about replica set. Of course, we push sorry, many new versions about our deployment, and we keep the history. And if we keep the history, that means that we keep the previous manifest. And if we keep previous manifest, that means maybe we keep something about, so we keep some stuff into the replica set. So to check it, so we can check here, kubectl get rs for replica set, and what we can see that we have our current replica set for the current deployment with our latest version, so the 1.27.1. Okay, we have 30 pod, and this is the desired state, and the current pod is 30 and ready 30. Okay, and you can see for previous revision we have each and previous replica set. And if we check, for example, here kubectl describe or kubectl get replica set, and the name of this replica set -o YAML, you can see you have our previous revision, and you can see here previous revision, and you can see the tag, of course, of our Nginx image here. And we have the 1.26.1. Of course, we are now in 1.27.1, and just before the previous revision, and the previous, of course, replica set is set with a tag 1.26.1. So perfect. This is the same thing. So this is really, really interesting to know it. And if you check during a rolling update, for example here, we can push again here a new version set to, for example, .3 here. And if I push again kubectl apply -f my Nginx and kubectl get replica set, you can see the deployment, and you can see here the previous version is with 29 pods and now 26, but in the same time the other and the newest replica set increase again and again and again to have 30 pods into it. And you can pause it, for example, if you have many pods and replicas. Of course, you can use kubectl rollout pause to be sure that if you have an error, and we can test it. Of course, you can use, for example, we want to push another version, and we can push it again. And to do that, we can use kubectl rollout pause. So kubectl apply and kubectl get replica set and kubectl rollout pause and the deployment and the name of the deployment, my Nginx, for example. So this is rollout, like here. Okay, perfect. And now if I kubectl get replica set, we are in pause. Okay, and you can check some stuff, etc. to be sure. If you want, you can roll back, and if your check is good, you can continue. And to do that, you can use kubectl rollout resume to continue your action. And to do that, of course, you can reuse this command and remove pause and set it to resume. And now you can see on the left, we can continue to have 30 pods into our deployment. So this is like a rollback, of course, because we go to the previous revision. Of course, we just change the tag and we already have the previous tag, of course. Okay, so that's it for today. I hope this video is really useful for you. Don't hesitate to share this video, to subscribe to the channel to not miss the next video, and like it and comment it to support me, and see you in the next one. Bye bye.